Hello, everyone. We're talking trig again today. We have one more day of evaluating trig functions. And today we're working with just some special angles. Yesterday, we talked all about the last video, we talked all about how to evaluate any angle, but there's some angles out there that have some pretty special qualities where you might only know the angle and not any of the side lengths, but we can actually still go through and figure out what the value of these trig functions are going to be. And we do have to remind ourselves a little bit about what we call the special right triangles. And these have pretty specific angles. These are what we call our 30 degrees, 60 degrees, and 90-degree angles, 30, 60, 90, or you have your what's called a 45, 45, 90 triangle. Anytime you have these two specific types of triangles, what happens is that there's always a preset length of those triangles. And that's because of the fact that that angle always produces side lengths that end up reducing in these ratios. So it doesn't mean your angles are always going to be the same, but it does mean that since we reduce fractions, they're all going to reduce to these specific side lengths. So if you guys will remember, in a 45, 45, 90 triangle, these guys always have legs of length 1 and a hypotenuse of √2. And if you work with any 30, 60, 90, doesn't matter the orientation, across from the 30 is always going to be a side length of 1. Across from the hypotenuse, across from the 90-degree angle, always has a length of 2. So it's always double whatever's across from the 30. And then across from the 60, it always has a side length of √3. So these triangles you are going to have to know because these are the preset lengths of each of the angles that we work with. So our goal is still to evaluate trig functions. We're just going to be doing this using those side lengths instead of lengths that I'm giving you basically. So let's start off with our first one. We are trying to find what the tangent of 240 degrees. Now in the back of my mind, I'm thinking that tangent, and if you remember our SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in the back of my mind, I know that tangent is going to be opposite over adjacent. Now that requires me to know what the opposite side is and what the adjacent side is. So of which I kind of don't know any of that information. So let's start by just drawing a picture and kind of seeing what we have to work with. So let's start by finding 240 degrees on my graph. So let's see, 180 I know would be halfway around, 270 would be 3/4 of the way around. So if I'm working with 240 degrees, my angle is definitely going to be in here. Now, we do need to find the reference angle though, because the reference angle is going to be what allows us to find what the missing side lengths of this is going to be. Because really, if you think about it, that angle, we can kind of turn this into a pretty neat right triangle. So if I can find out this angle right here, which is my reference angle, then we're going to be in business. So the problem is though, right now I don't know the reference angle. Right now I know this angle, which is 240 degrees. So to find my reference angle, we're going to take 240 degrees and I'm going to subtract off 180. So if I take 240 minus 180, we get a reference angle of 60 degrees. This right here is my special right triangle. Because if that's 60, that means the other angle opposite this is going to be 30. We have a 30, 60, 90 triangle. So even though I didn't give you any side lengths, because you know the side lengths for a 30, 60, 90 triangle, we can fill these in and we can still evaluate this trig function. So across from the 30 is always going to be a side length of 1. Across from, or the hypotenuse across from the 90 is always a side length of 2. And across from the 60, it's always a side length of √3. Now, in terms of trig functions, we do want to kind of keep in mind the quadrant that we're in. If I'm in quadrant 3, really, if there was a point here, we don't have a point. I know we don't, but if we did, hopefully you would agree that whatever the x coordinate would be, it would be negative. and whatever the y-coordinate would also be negative. So that just tells me that my two side lengths to get down to that point, I have to go left a certain amount and down a certain amount. And both of those on a grid are negative distances. So here's the cool part. You now know all of your side lengths. If I'm going to then notate my opposite, hypotenuse, and adjacent, well, this angle right here, that is our angle. So the adjacent side is going to be -1. The opposite side is going to be -√3. And the hypotenuse is going to be 2. So if I'm going to find my opposite over adjacent, that just tells me my opposite side is going to be -√3 over my adjacent side, which is going to be -1. And simplifying a negative divided by a negative just leaves me with +√3. Now, we do not convert to decimals in this part of the unit. We always want to leave our answers as exact, but that right there is the value of tangent of 240. Now, you can still check your answer. If we go into our calculator, we just want to go to our mode. And remember, you do want to make sure that you are in degree mode. So hit the mode and then arrow down to where it says degree, and then we can quit out of that. So if I check out my final answer here, if I try typing in tangent of 240 degrees, we get this. And if I try typing in the square root of 3, you get the same thing. So the decimal is great to check your answer, but we don't ever write our answer as the decimal. We keep it as whatever the original square root would be. So that's it. That is the value of tangent of 240. So let's work through some of the other ones. So my next one says we're going to be finding sine of 315. So we're going to do, again, a kind of a quick sketch. Now 315 is definitely more than 270. It's in between 270, wow, and 360, not 370. So I know 350 degrees, that's going to fall obviously in quadrant 4. So if we kind of think about this like a mini right triangle, I know it's not a right triangle, but it is going to help us kind of figure out our side lengths. Now, what we don't know right now is our reference angle. I know that all the way around, that's 315 degrees, but my reference angle is this angle right here. So if I want to find my angle, I'm going to take, obviously, we're going to take the larger one, 360, and I'm going to subtract my angle here, which is 315 degrees. And that's going to give us, what do you know, 45 degrees. We have right now a special right triangle. This angle is 45. This angle is 45. And in a 45, 45, 90 triangle, these are the given side lengths. Across from the 45s, the legs are of length 1, and the hypotenuse across from the 90 degrees is always going to be a side length of √2. So let's fill them in. Across from my 90s are going to have side lengths of 1. Hypotenuse is going to have a side length of √2. Now we do want to take care of sines because if my angle falls in quadrant 4, I have to go right and then down. So right just means that it's going to be positive. Down just means it's going to be negative. And now we can find our function. Sine we already know is going to be opposite over hypotenuse. So if we look at our opposite over hypotenuse here, the opposite side, opposite side is going to be my -1, and my adjacent side is going to be, not my adjacent, hypotenuse is going to be √2. So if we fill in the rest of our trig function, we're going to have opposite, which is -1, over hypotenuse, which is √2. Now remember, we can't have square roots in the bottom. So to get rid of it, we just multiply by whatever's in our denominator. So on the numerator, -1 times √2 is going to be -√2. On the bottom, √2 times √2 technically simplifies to the square root of 4, and the square root of 4 is 2. And that would be our final answer here. Now, Miss Hardy did forget a negative. Man, Miss Hardy. I dropped the negative here, but it would be -√2 over 2. Now, you might be working with even some that could potentially be like cosecant or some of our reciprocal functions. But remember, it does help to kind of keep in mind which reciprocal it's of. Cosecant, I always know, is the reciprocal of sine. So that's something to kind of keep in mind. I'm still looking for the opposite and the hypotenuse. but it's just a matter of where this is actually going to end up falling. So let's get a picture of this. Let's draw and find out where my angle is. Now 150 I know is more than 90, but less than 180 degrees. So my angle is definitely going to be falling in quadrant 2 in this problem. So if we kind of think of this as a right triangle, this angle right here is going to be 150 degrees. So to get to 180, my reference angle would be whatever the difference between 180 and 150 is, and I know that angle is going to be 30 degrees. So all of these, you should end up with a reference angle of something that's either a 30 or a 60 or a 45. And that just means this one we're working with a 30, 60, 90 triangle. So if we start to know our side lengths, across from the 30 is a side length of 1. Across from the 90 is going to have a side length of 2. And across from the 60 is going to have a side length of root 3. Now we take care of signs because my angle is in quadrant 2. And to get there, I have to go left and up. So the left distance has to be negative and the up is always positive. And now we can find our value. So cosecant, is the opposite of sine. So if sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. And our opposite side, it looks like on this one, is 1. Hypotenuse, wow, why does that keep happening? Hypotenuse is going to be 2. So hypotenuse, fill that in. That's going to be 2 over our opposite side, which is going to be 1. And 2 divided by 1 is 2. So really, guys, that's kind of the whole point of today. Now, there are some cases where we could be working with quadrantal angles. And quadrantal angles are the ones that are a little bit odd. These are the ones, when we say quadrantal angles, we literally mean the angles that would fall on the quadrants. Now, these are a little bit odd because they don't really have a technical reference angle. Because of the fact the reference angles are always formed with their x-axis. So if I pick, for example, my angle up here, if I pick this angle here, an angle that would fall up here, if I drop my reference angle, that would be my measurement. But really that measurement with the x-axis, because it's vertical, that's really hard to talk about. So what we do instead is we use the fact that on the quadrants, all of these have a distance of 1 away from 0, 0, away from our origin. So what happens is that all of those values still technically have a point. To get to our point over here, I have to go right 1, up or down 0. To get to my top one, I have to go left or right 0, up 1. To get to my left one, to get to 180 degrees, we have to go left 1, up or down 0. And to get to 270 degrees, we have to go left or right 0, down 1. So what we do is we kind of do a mock triangle because there's not really like an angle in here. So off to the side, what we can do is most angles, no matter where they would fall, have kind of a preset triangle that's given. And we always use a hypotenuse of 1. And to get to most angles, it's always going to be the x coordinate is the horizontal distance and the y coordinate is the vertical distance. So even though when you find angles that fall in a quadrant, we can still kind of use that concept of opposite, hypotenuse, and adjacent, even though it doesn't really form a technical right triangle. So for example, let's look at some examples. So for our first one, tangent of 270, we would start by obviously finding that on our grid. And you're going to come to notice that 270 obviously is on my negative y-axis. So the point that's associated with this, if I go left or right 0, down 1, here off to the side, I'm just going to draw kind of a mock triangle for this. So the horizontal piece, my x coordinate, I'm going left or right 0, and I'm going down 1. And my hypotenuse is always going to be a value of 1. So when we evaluate tangent of 270, we can still use the concept of opposite, hypotenuse, and adjacent. Opposite of my angle here would be this side here. That would be my opposite side. Hypotenuse is the one across from the 90. Adjacent is the one next to it. That's not the hypotenuse. So if tangent is opposite over adjacent, my opposite side is going to be -1 over my adjacent side, which is 0. But this is where we do run into a slight issue because we're not allowed to divide by 0. So if you have -1 divided by 0, that just tells me our answer is undefined. There are certain trig functions that you actually can't find the value of because of the fact that it's undefined. Anytime you end up dividing by 0, you found something that ends up not working. Now, let's say we work with something here. It's only when we divide by 0. Now, if you're not as comfy working in radians, that's okay. You can go through and convert this into degrees. Now, I know that cosine of pi halves, if you want to convert this to degrees, pi halves, we're going to multiply by 180 over pi. The pi's are going to cancel. So if I take 180 divided by 2, we're going to get 90 degrees. So on my coordinate grid, 90 degrees would be the positive y-axis. And the point, I go left to right 0, and I go up 1 to get to that point. So if we kind of think of our triangle off to the side, our angle, it's always going to be the x coordinate is the horizontal one. So we're going left to right 0. And the vertical component is going to be 1 because that's the amount up that I'm going. And hypotenuse is always 1. So cosine, if I think SOHCAHTOA, cosine is always adjacent over hypotenuse. So in my triangle, we know that across from my angle, that's obviously going to be the opposite. Across from the 90 is the hypotenuse. Next to it is the adjacent. So my value adjacent is going to be not 0, sorry. Adjacent is going to be 0 and my hypotenuse is going to be 1. Now here, this is totally fine. I can do 0 divided by 1. And that just tells me my final answer is going to be 0 on this one. All right. So in terms of our angles, it really just depends kind of where we fall. And then obviously drawing kind of the triangle that goes with it. So you guys can now move on and you guys can get started on the homework for the day.